Hello, hello. Okay, so here is a video on state management. Now I decided to also make it informal, so this video won't be publicly available to everyone. It's going to be unlisted. One reason is that in lieu of the changes to classes, I don't want to show any code that is functional. Functional, that uses functions as constructors. Everything is going to be refactored to classes, but also the channel Mambo.js needs to be strictly about Mambo.js products and the UI, the components, and it shouldn't be too much about comparing how Mambo.js works compared to everyone else. So that's why also all the materials that I did before, they will remain public. So, sorry, they will remain unlisted. So this is going to be one of them. And so here, let's get started. So I got 5 slides here where we'll be covering the evolution of state management over the past 8, probably 10 years. It's been a decade already. So one of the first ways was the namespace. Then we have Jquery that also used namespaces also. So it was a combination of Jquery and namespaces, and then came Angular React View with this entire nonsense of Redux, and NGRX reactive. They're all the same. That's why we're going to cover it all together. And then we have the observable, which is slightly different. It works, it's actually something that I like for a event-driven architecture, which is the upcoming videos. So it is the observable design in a way, but I don't use it for state management. And then finally, the state management that I favor, which is, this is radically different. On the case of namespace, Jquery, and React Angular View, they're all the same. So let's just cover this historical changes really quick. So namespace, it was basically to the window object, you add a property with your namespace, whatever you want to call it, and you initialize it with an empty object, and then the properties of that object would be functions and key value pair data state and logic. And so you have component A, B, and C, and whenever any piece of state of any given component had to be shared through the application, then you would put that data directly into the namespace. And then you would use functions to retrieve it. You could also use functions to pass your data in. So that was it, depending on the usage of the application. But basically you use functions, put data there, and then when component B wanted to access it, it will go into the namespace and just get that piece of data. So that works, but it's very disorganized and basically forces you to put application data and logic outside of the component that is supposedly managing that piece of state. So that is a very important thing to realize here, that the state has been generated, has been created by component A. So component A knows all the in and outs about that logic. And then in order to share it with B, now we have to take that data outside of the component and put it somewhere where component B can access it. And that starts to create a lot of work, a lot of additional work, because now we're no longer just creating the application and the logic for each component. Now we have to deal with creating all these functions and this logic to figure out a way to share it between them. So that's additional unnecessary work. Then came Jquery. like I said, jQuery also used used the namespaces as well. It had nothing to do with jQuery, but jQuery added its own object, and also because jQuery made it easier to work with the DOM, then people started to basically put data in the DOM via the attribute method. But this data here is basically it's a method that that sets and gets data from an empty object that exists within the jQuery library. So somewhere inside jQuery, they created an empty object somewhere in there. And then with the data method, you could put data and retrieve data. And so as you can see, it's the same thing as namespace, exactly the same, but done in a different way. And so now let's look at some code really quick. Looking at namespaces. So you can see basically, so what we do is we have an employee state. This employee state has three methods, three functions that return some piece of information, some data. So as you can see, this is very much like a reducer type of thing, right? And then you have the company, also piece of data that has the same, it has some methods and it retrieves some data, and you can use the same to put data in here, right? You can basically pass data in, when you call the function, you pass some data in and you store it and so on. And then you will create your namespace, right? You put this on the window object, right? So it will be something like window dot my namespace equals, that object, right? Something like that. Let me just do it right. That was wrong. It's like this, window dot, okay? Window dot my space equals that object. So you have your namespace, it's an empty object, and then you say my namespace employee equals that employee, that piece of state, and then your company. And so now you can access those methods through the namespace. And as you can see, this will become very hard to manage. And you basically don't know what is what, right? You have to just know, oh yeah, this employee is certain thing. But it gets to a point that you have a massive object with so much data, and you just don't know what is what, unless you know the application, unless you wrote it yourself, unless you work with it already. It's just pretty obscure. Then we have the jQuery example. So as you can see, we had the typical document ready, jQuery, and then you can go to the body element and call the data method and pass some data in it. This one is an array. The property foo will have a value of 52. You can retrieve it like so, and then if you call just data without passing anything in, it will return the entire state. And as you can see, it's an object, right? Everything is just an object. And then the other way was through the attributes, right? You had a DOM element, you create your own custom attributes with data dash name, and then you would go after that element using the attribute method and fetch that data. So this will console log Alejandro, which is the value of that attribute, right? Yeah, so people use this, which is insane, but it worked for a little while. So we'll just close that out, and now let's move on to the heavy hitters here, the React, Angular, and Vue. And it doesn't matter how cool the names are, store, reducer, blah blah blah. It's basically the same thing. It's all functional. You have an empty object. You start off with an empty object, and then through reducers, which is basically functions and logic, you set and get data from that object. And then whatever state a component has created or will create that needs to be shared amongst other components, then it needs to go into the store, because there is no communication, direct communication here between these components, right? So, but you can see it's the exact same thing. So now let's look at this code really quick. So these people managed to take something that was already bad and make it 10 times worse. It's this is the original setup of Redux. It's not the toolkit or the, I think there's another Flux or whatever came after. The same with Vue. You know, we have Vue is basically following the same pattern, but this Vue code example here is modern. So it's, you can see that it is slightly more, it's slightly cleaner, easier to understand, but it is exactly the same thing. You know, you got a Vue store, right? Reactive from Vue, create your store. You got your reducers and you got your piece of state. Is the exact same thing. And then your components, you know, component A has to bring the store, you know, and then you gotta bind it to, you know, now your click event is now that reducer is the exact same thing. Pretty awful. So now let's look at the, yeah, so this is the original Redux, not the ones that came after. So the boilerplate is the worst that it has ever been. So a lot of people will argue that, oh well, but that was back then. Yeah, well, back then they were selling this like, you know, the best thing ever. And then when they finally fixed it a little bit, they say, okay, so now this state management is the best thing ever. And then the next one is the best thing ever. And it's all the same thing, because the issue, a big issue with this that no one talks about, is that namespace is a functional design, not object-oriented. jQuery is functional design, not object-oriented. This is also functional design. This observable is functional design. My way of doing it is not functional design. And just to confirm what I mean, to clarify, what I mean by functional design and object-oriented is the fact that in object-oriented, you create each component, you create an instance of that object using the new keyword. You will notice that in React, Angular, Vue, you never use the new keyword, and you never have access to the instance of that object. So you could call public methods of that object. That's what I mean by functional. Everything here is functional. The only way that you can pass data from component A to component B is to create a function that you can call from multiple places just so you can get that piece of data. Okay? And so here, looking at the Redux, this insanity here is you have to wrap your app with the provider, right? So here's the provider from React Redux. Then you create the store that you bring in also from Redux, and then you have to import your reducer. Then you call the create store function. You pass in your reducers. I don't know what the heck this is. And then you take that store and you feed it into the provider. So this nonsense right here, all it does is feeding the empty object into all the applications, so it's available to any component that imports that store into the component. So now going into the app, now we have the application, not the application. So we have the app, we're rendering this, some div, we have a header, and then we have the counter. This, basically this code example, what it is, it's just this. It's 3 buttons that increment and decrement and reset. You've probably seen these many times already, this type of silly code practices. And so here's where things start to get pretty stupid. So we have a counter, right? We're importing the counter here, and the problem here is, so the counter needs to access those reducers. So how do you feed your reducers into the counter? So well, you have to wrap it with a counter container. And if you see this counter container on the app, what we're bringing here, we're bringing the counter, but we're bringing it from the what is this app contain? Oh, this code is wrong. Oh, never mind. So forget about that. Scratch that. Anyways, so what's happening here is that you have to import your reducers. But in order for this to work, you have to create a counter container. So you have to wrap your container with a container that basically does all the mapping of your store. Can you do it differently? Sure. I think you can do it without a container, but you basically have to wrap your counter, everything, all the logic has to be in one file, but you have to do it anyways. So this insanity here, you have to call the connect function from Redux, and you have to pass it 2 arguments, where you have to manually choose what state props, what state keys you're going to pass into the counter. So you have to manually, see the map state to props is giving you the entire state of the entire application. And now you have to manually map it, create a new object, and say, okay, so the state is going to come in the property counter, and that's going to be the state. So that's why in the counter here, this counter is the state. So you have to map whatever state you want to use inside counter. Now you have to map it in the container. And then you also have to now map the dispatch to props, which basically you have to map the reducer functions into the props so you can grab them here and use them. So these are this counter is the state, is the object, and these are the functions from the reducers. See? So this is so awful. And so you gotta call the connect, pass the mapping arguments, and then that returns a function that you call now, you invoke, and when you invoke that, then you pass your actual counter, which is the one that has the HTML that you want to show. And so that's how you wire this entire thing. But look at this insanity here, and all this is 3 freaking buttons. Like imagine when you have real complexity, how hard it is to work with this. And so one of the first argument I can tell you right now about this is, why in hell does the logic for the click event not exist inside this counter component? So what's crazy here is that we are creating these reducers that handle logic related to an event that should exist inside the counter. So now here as a developer, I'm looking at this, increment. Oh, what does the increment do? Of course, this is a simple example. So yeah, we know what it is. But what happens when you have some real complexity? So now I have to go into whatever that reducer is, and look at the complexity. But we're talking about real complexity. It's not going to be 1 or 2 lines of code. We're talking about 10, 15, 20 lines of code whenever you do a click. And now it exists outside the component. So it's harder for me as a human being, much harder for me to manage this, to remember, oh, gotta come here. Oh, what was it? Remember, it's doing this, and then I'm coming here. So I gotta do this, and then you keep switching back and forth. And that's only a simple example, because on a real application, you're gonna be dealing with tons of state. So you're gonna have to be importing all sorts of reducers from all over the freaking place, and then you have to be consuming those functions all over the flicking place, and all of that logic and state does not exist in this component. Everything is somewhere else. So you don't see it, you don't read it, you have to go look for it and then go back and forth, and then next time you know, you're jumping around from here to there, from here to there, from here to there, and all that logic should exist in the component that is dealing with the logic. It should all be here, the state, the logic, and the HTML. It should all be in one place. But the problem with this is that this React, Angular, and Vue are functional design. So if you have all of that logic inside the function, inside the class, then how do you share it with other components? And the answer is you cannot. You cannot do it unless when you call the counter, you pass in some other props. But at the end of the day, it's the same thing. You end up creating the same thing. That's why they ended up creating Redux and all this state management, because at the end of the day, if you are in a functional design, if it's not object oriented, you're screwed. There is no other way of doing this. So if I had to build a state management in a functional design and object oriented is not an option, guess what? I end up with the same thing. So I'm not saying that there is a better way of doing this in functional. You can't. It's just the way it's just what it is. They ditched React and Angular and Vue. They ditched the entire object-oriented concept, and so this is what you end up with. So the mistake is the single biggest mistake they made is to not take advantage of object-oriented architecture. So that's why the market is where it is today, and we have all this insanity of tools and a gazillion functions that are being passed around all over the freaking place in the application. Well, enough name calling and trashing everybody. Let's just look into how I like to work with things. Going back to the slide. So this is my way, the way I was taught 7 years ago by a Java developer, senior Java developer. And of course, at first I was like, okay, I just don't get this. It took me a while to get it. But basically what happens here is we are now in a object-oriented architecture. What it means is that we create instances of functions or classes. And as you know by now, in such object-oriented environment, we have the ability, let me see if I have some code here. Let's open a component. Let's open the input. So in an object-oriented, like I explained to you guys a million times, when you are in an object-oriented architecture and you use instances of objects, you have the ability to create your own public methods, which are in essence APIs, right? Application Public Interface. So this basically is every component has an API. An API is basically Application Public Interface. And what it does, it allows you to interact with the inner workings of your component directly from the outside. So we choose here. So I say this is a Mambo input. So a Mambo input, yeah, it's an input field. And basically you can see right here we have a clear method. Obviously you already know what it does, a clear. If I go to the clear, so when you call the clear input from the outside, you're basically telling that input tag the value will be empty. So you're basically clearing the input field. And then we have this one here called value. So if you call the value function, what you get is the value of that input tag, and that is the state. So the Mambo input knows entirely its own logic and it handles its own state. It knows everything about itself. It knows its state, it knows its logic, and knowing what it does, you know what you need to expose for whoever is consuming this component to work with. So whenever you call a Mambo input because you need an input field, then I know, okay, this is an input field. What would an input field do? Okay, you need to clear the input. You need to get the value from the input. You might want to get the actual tag, the DOM element tag. You might want to check if the data has changed. Then you can say you can commit a data change. This is some inner workings. So basically, this is how you work with the state of the Mambo input. And then the button is the same thing. We have the Mambo button and we have its API. You want to get the text of the button. You want to select the button. You might want to deselect the button. You might want to enable it or disable it. You need to get the ID of that instance of the button and so on. So going back to this logic, basically this state management means that there is no state management architecture that exists anywhere in a central location that says, here is where we are storing our state management. So all the responsibility for state management resides at the component level. It doesn't matter what component it is. It could be a reusable component, or it might not be a reusable component. Whatever that is, you are building a component and you know what it does. You have a purpose for developing that component. You know, is it an input? Is it a button? Is it a grid? Is it a video player? Maybe it's just a view that is not reusable. Maybe it's a chat room. Maybe I'm loading the entire view of a chat room and it's not reusable. So I'm loading the chat room. Okay, what is the chat room supposed to do? Okay, it handles how many users are logged in. So the chat room component goes and says, okay, where are the logged in users? It gets that data from wherever that may be, maybe from a server, from an API, from WebRTC, who knows? It gets the data and it does with it whatever it needs to do. And then the chat room says, okay, so I have certain functionality. So maybe my parent component, whatever component instantiated a chat, might want to control it. Okay, so what do I need to expose through the API of the chat room that needs to be controlled from the outside? So there might be an option, maybe the application says, hey, you know what, we need to reset the entire chat. We need to have a button that says reset the entire chat. Okay, so you make in the chat room component, you make an API that says clear. So when you call the clear method of the chat room will basically go through the logic and say, I know what I'm doing. I know what components I have instantiated. I know what's going on with myself, so I'm going to clear everything. And then you run the logic and you clear and you do what you need to do. And that's basically what this is about. When you have an instance manager, so this is an object, like we said, everything is an object. We're going to look into the code of this right now. But this is something that you need to understand. That's what's happening is everything in JavaScript is a reference, meaning that you create the instance of an object and that object gets stored somewhere in memory. The actual memory, the actual hardware of your device, it's put somewhere in the memory. And so the JavaScript that runs in the background in the processor does all that low level, 101010 communications. It says, okay, well, we're creating an instance of the child class D, and that piece of memory we'll put it somewhere. And so that is the one single instance of that class, and that's where everything gets stored. It's in memory. And so that is an instance of that one class. And so what I need to do is, okay, so the child, let's do an example here with class D and class C. So class D needs to know something about class C. And so in the application, wherever I created the instance of this class C, I'm going to automatically save it into the instance manager. But when I say save, I'm not saying that I'm saving a copy of class C. All I'm saving is where in memory that instance is. So where do I go find that instance? That's what is generally being saved. So we're not duplicating classes here or instances or anything. It's almost like an address, right? When someone says, hey, where do you live? Oh yeah, my home address is this and that. You're not giving them the home, right? You're just telling them, here's the address. That's where my home is. If you want it, you know where to go. You go get it. There's only one home. I have only one home. This is the same case. You save the address of where that instance exists in a place where anybody, so you can, any other class, any other component can go and get it. So you could call this object instance directory, or you could have a similar name like that. Object, instance directory could be also, but manager is fine. And so I have covered this before on the tutorials for object oriented. But let's cover it. Let me close. Let me open this again. Is the Mambo, this object manager. So basically, this, look what it is. It's just nothing. It's literally 16 lines of code, and shorter if I remove a couple lines here. So this basically, we start with the same thing. It's an empty object, but the difference is that we don't put any data, any state, any logic, or any function with logic inside this object. The only purpose is to save the instances. And so we have a get method that goes to the store, and it gives you the address of that instance, where to get it. It basically gives you the instance to work with. And we have a save. The save has a little bit of logic. So when you call the save, you're passing that instance of that object. So this parameter here is the instance, and you could give it a name if you want to save it under some other name, whatever name you want to give it. So this name is optional. So if you provided a name, then we're going to save that instance under that name. Otherwise, we're going to assume that this is a constructor object, therefore it has a name. That name would be Mambo button, Mambo input, chat room, whatever was the name of that function or class. That is the constructor name. And so it gets saved into the store under that object name property, and we save the instance. And it's that simple. So again, in case it's not clear, we're not saving data, state, logic, functions, nothing, only the instances. Could we save a function if we want to? Of course, and it's actually valid. In some cases, you might need to put some data there that is not being managed by an instance of anything. It might be a regular, an object literal, it might be an array, it might be whatever. That's valid too. But when it comes to the perspective of state management, the state is being managed by the components themselves, where the logic of that state exists, and you have your API to work with. And so now let's do a little bit of example here. Let's go to the initializer. This Mambo initializer is basically where this is something that will load when the application loads. We need to instantiate the DOM.js for DOM manipulation, and we instantiate the object manager, which is critical for our state management. And I put these two in a global variable, so it's accessible from anywhere. And then I'm saving here on the object manager, I'm saving Mambo utilities, event manager, event directory. I'm saving some utilities that are going to be used. And I don't want to be creating new instances of these everywhere, so I create one instance, and then whoever needs it goes and gets it from the object manager. So just to give a very quick code example, like I said before, child class D needs to access something. of class C. So the way that would work is, just an example here, we have, let's do class child C. Yeah, so we have C, and we have the constructor. Okay, and then we have class, what was the other class? D. So they had D and C. So we have D. So I do, object manager, save, new, child C. And now I created a new instance and I automatically saved it into child C. What I could have done also is child C equals, this is the same thing in essence. Now in some case, if I do this, I can also do child, I also have access to the API. You know, maybe it has a method start, right? And you call it like this. If you need to interact with that instance in the same place where you created the instance, then you will store it in a variable so you can use it in that component, and then you save it, right? So now that this is saved, this child D, this child D could be anywhere in the application, could be super far away, that is not accessible directly from child. Right. So child D is in a place where this instance of child C is not accessible directly. So we need to find a way to fetch it. So here inside the child D, we'll put it inside the constructor. We will say, I need access to child C. So const child C equals G object manager, and now I do a get instead of a save. I do a get, and I pass the name of that class as a string. And so now this instance here is exactly the same instance as this. It's exactly the same. So if anything changes on this instance of child C, it's automatically, instantly available in child C. Instantly. So child D doesn't have to get notified that something changed. It's automatic. There's a lot of things that happen automatically. So now child C has access to it, and so now child D has access to child C, and now child D can also call the method start from child C. Maybe child D needs to know status, so maybe there is a method called status. So maybe child C has a method called status, right? So to make this example actually correct, let's do this. We're gonna have start, we have the method start, and we have the method status. Okay, so now the code is actually correct, right? And so that is the core of object-oriented state management. This is so Java. This is super Java-like. This is how you work in Java, and I'm assuming that you would do the same in C#. I've never worked with C#, but you can also do the same in PHP, in object-oriented PHP. You can do this as well. So it's the same thing. Basically, you are using APIs, and you create those APIs, those methods, as getters and setters for state. And that's it. There's nothing else to it. So I hope you enjoy this video, and I will talk to you soon. Take care, guys. Bye.